Hey folks, Mrs. White here. This is your last official video for the year. Can you believe it? I can't believe it. I am psyched. I hope you are psyched too. We did it. We made it. One last thing for you folks to complete, and you are free from math for the summer, okay? If you still owe me any late work, you're welcome to hand that work in through Friday. Remembering that you want to try to tie up those loose ends before the summer hits, so there's nothing that you end up having to make up next year. Okay, so let's get right to it. Today we're going to review for an upcoming quiz. This quiz does not have to be proctored by a parent. However, when you are ready to take the quiz, you are going to email me right before you get started. That way I know who's working on it and when. I don't need to proctor you per se, but once I email it back out to you, I'm expecting that you're working on it, and then you can resubmit it on Classroom. So we're going to start by going over what's on the quiz. So what can you expect from it? Your quiz is 9 questions. Out of those 9 questions, the first 2 of them involve creating a graph of an exponential relationship. So you're going to have one exponential growth, one exponential decay. I will let you know that those are medium to hard problems, okay? They do involve potentially fractions. Remember, when you're dealing with exponential decay, there's a fraction in there for sure as your growth factor. Then you're going to have a handful of multiple choice problems. In fact, all of the following 7 are going to be multiple choice. Out of those 7, 5 of them, actually not 5 of them, 3 of them are going to be solving. 2 of them are going to be word problems, but they're multiple choice, so that's kind of nice. And then 2 of them are going to be identifying whether it's growth or decay. Okay, so those are like really nice. So that gives you all 9 problems. So 2 of them are going to be graphing. The other 7 are multiple choice. 3 of them are going to be solving. 2 of them are going to be word problems that are still multiple choice. And then 2 of them are going to be identifying whether something is exponential growth or exponential decay. So let's take a look at all of these items, okay? So we're going to start off by doing a couple graphs together just to refresh your memory. Then we will actually do 3 solving equations, and then we'll do 2 word problems. So we're doing pretty much the same amount of work in this review as there is in your quiz. I attached on Classroom a separate review sheet and a separate key. So if you're like, man, after hearing Mrs. White go over those 2 graphs, I'm nervous about graphing, go on, check out the review problems and the key, okay? If you feel great about graphs, don't bother, okay? In fact, I'm not assigning any review work at all. You do not have to turn in any review work. I just want to give you additional resources if you wanted them, okay? What I am requiring that you do is once you feel good and you're ready to take this quiz, you pop me an email. I will forward the quiz to you. You'll complete it and then put it right on Classroom when you're done, okay? There is one other thing, since this is my last video. On Wednesday, I am going to put out a feedback survey. Okay, so I want to know, how did remote learning go for you? What areas did I do well that I could consider continuing in the future if we have to do remote learning again? Or what areas and what types of things could I do to improve how I ran things on Google Classroom and virtually for this quarter? And honestly, I don't know exactly from everybody how things went. Okay, some of you I got to see during office hours, some of you I didn't. So this feedback survey is really going to help me to improve my practice. Okay, I'm going to read through it. You're welcome to not put your name on it. It will not collect your email. You can leave me anonymous feedback, but make sure it's constructive, folks, so that I can make some changes in the future if I need to. Okay? So that won't be coming out until Wednesday, so don't fret about that now, but please consider filling it out so that I can improve what I do. So let's take a look at these 2 graphs, all right? You're going to have, one of these is exponential growth and one of them is decay. So I'm going to look at the equations. I'm going to look at the base that holds up my exponent. If that base is greater than 1, it's exponential growth. So this is exponential growth. 1/2 is clearly less than 1, so that is exponential decay. So exponential growth should start out slow and then really increase. Exponential decay starts out with steep decreasing and then it kind of evens out towards the bottom. Okay, so to graph these, I take my exponent, which happens to just be x here, and I'm going to set it equal to -1, equal to 0, and equal to +1. And it just so happens that each of these are x's, so I don't need to rearrange them. So I'm going to start making my table. My x's are going to be, because there's nothing to move over, -1, 0, and 1. And I'm going to plug each of those values into my equation and get out the y for my point. So I'm going to have 1.5, times 2 to the negative 1, because that's what I'm plugging in for x. Anything to the negative 1 means change its location. So I actually have 1.5 times 1/2. So anything that I do when I times 1/2, I could do this. I could go across the top, across the bottom, and I'm going to get 1.5 over 2. I don't know what that is offhand, so I would do 1.5 on my calculator and actually divide it by 2. I do know it offhand. It's 0.75. So my first point, I'm going to go over to negative 1. I'm going to go up 3/4 of a box. My next point, I'm going to plug in 0 for my exponent. So a 0 here, and I'm going to rewrite everything else. So I'm going to have 1.5 times 2 to the 0 equals, now anything to the 0 is the same as 1. So I have 1.5 times 1, which is just 1.5. So I'm going to go over 0 and up 1.5 boxes. My final point is going to be 1 in for this exponent right here. So I'm going to have 1.5 times 2 to the first, which is just 2. Or 1.5 times 2, which is 3. So I'm going to go over to 1, up to 3. Now you can see here's the general shape, right? It's maybe a little bit flatter here, and then wow, it's starting to increase steeply. One thing we didn't talk about is the asymptote. I should probably graph that first. There's nothing being added or subtracted here, so I'm going to have an asymptote right on the x-axis, right at 0. Now I'm ready to connect my dots. I'm going to have it hug that asymptote here and continue up in this direction. Okay? Perfect, beautiful, love it. I'm going to look at my next one. Oh, I should have chosen one that had a hot mess going on in the exponent here. But again, we would take whatever our exponent is, set it equal to negative 1. Take your exponent, set it equal to 0. Take your exponent, set it equal to positive 1. And hopefully we've done enough other practice in our sit and begins that this feels familiar. I don't have anything I'd have to move over. If this was a 2x, I'd have to divide by 2 every time or something. But I am going to keep my negative 1, my 0, and my 1. And now I'm just going to plug each of these values in to my equation and PEMDAS the crap out of it. So I'm going to have 5 times 1/2 to the negative 1. But don't forget there's also a -8. Now before we get too far into this, I do want to talk about that -8. That -8 is going to be an asymptote, okay? So I'm going to move that asymptote that originally was at 0, I'm going to move it down 8. Now the graph they connected to this doesn't have 8 boxes, so I'm going to continue with my points because I wonder if I'm going to have to do a scale here, okay? I wouldn't go over doing a scale if it wasn't something that you would potentially need in your quiz. All right, so let's continue with this problem. Anything to the negative 1 power means change the location, so I end up with 5 times 2 minus 8. 5 times 2 is 10. And 10 minus 8 is 2. So I'm going to go over, I would do negative 1, positive 2. So let's just keep going and see what happens. Like I said, I'll get all these points and then I'll figure out if I need a scale. Next, I'm going to plug in 0 for x right here. So I'm going to have 5 times 1/2 to the 0 minus 8. Anything to the 0 is the same thing as 1, and 5 times 1 is 5. So I have 5 minus 8, which equals negative 3. So I was at positive 2, now I'm down in the negatives. So lastly, I'm going to stick a 1 in for x, so that's going to just stay 1. So I'll have 5 times 1/2 to the 1 minus 8. Anything to the first power is just itself, so I'm going to do 5 over 2. Now 5 over 2, in my head, I know that it's 2.5. So I'm going to do 2.5 minus 8, which is going to be negative 5.5. And this does not go down 5.5. So I am going to do a scale here. I'm going to make my x's stay at 1, so I'm not going to write anything. But here I am going to mark that this is a negative 2, negative 4. Once you mark a couple of them, folks, I'll know what the scale is. So now I'm ready to put in, first I'm going to put my asymptote. So I'm going to move it down 8. So down 2, down 4, down 6, down 8 will be right here. Because I'm doing a scale of 2, right? And I need to make sure to mark that. Now I'm going to plot my points. I'll start off with this one, which is negative 1, and then positive 2. So negative 1, positive 2 is just one box. Remember, I'm doing a scale of 2 here. Next, I'm going to do over 0, down 3. So over 0, down 1, 2, 3. Negative 3 is right here. Now I'll do my last point. I'm going to go to positive 1, and then I'm going to go down, so scale of 1 here, down to negative 5.5. So here's negative 4. Here's negative 5. 5.5 is kind of like the 3/4 spot right there. okay? So this is good. I can see that this is my exponential decay, right? It starts out steep to the left, and then it's going to start hugging that asymptote, okay? And that asymptote was shifted down 8, makes perfect sense. This is what I'm expecting. You are going to have 2 graphing on your quiz. Again, if you need more practice, feel free to hit up that review sheet, and I did post the key online. The next problems you're going to have, besides identifying if it's growth or decay, is going to be solving. We have ones like this. I wouldn't show you a fraction one if you didn't need to know how to do it. Okay, so let's go through each of these. I'm going to go through them very quickly. So I'm going to look at both of my bases, and I want them to be prime factors of each other, okay? Or with the same base is what I mean to say. So they need to just be a prime factor. So I know 9 is 3 times 3, or 3 squared. And I'm going to have 3 squared, which is equivalent to 9, raised to the x plus 1. Then 27, I actually would factor tree it to the side, but I know 27 is 3 to the third. I've done a lot with these exponents. So I'm going to raise it like this. Now I notice they both have the same base, which is a good sign. I need to do my power rule, which means I'm going to distribute this, right? I multiply my exponents. I'm also going to cancel my bases at the same step, just to save time right now. So 2 times x is 2x. 2 times 1 is plus 2. 3 times x is 3x, and 3 times 4 is a plus 12. Now again, I canceled those bases because if they're the same bases, I just need my 2 exponents to be equal for the whole thing to be equivalent. I'm going to minus 2x minus 2x, which will give me an x over here. Then I'm going to minus 12 minus 12, which will give me a negative 10 here. And boom, there's my answer. X equals negative 10. Let's go to our next one. Okay, now in this problem, I noticed, wow, 36 probably could be broken into, I don't even know, 2's or something, but I also noticed that 36 is the same thing as 6 squared. Sorry. So I'm going to keep it like that for now, raised to the 2x plus 4. And I'm going to hope that this 216, I can divide in 6's into it, and I can raise it as a 6 to some power. So let's pull up that calculator. And let's do 216 divided by 6. Because remember, I want them to have the same base. Ooh, and I notice it's 36, and 36 is divisible by 6. So 216 is the same thing as 6 to the third power raised to the x plus 5. So these don't have to be prime as long as I can get both bases to be equal, okay? So since both bases are the same, I can use my power to power property. So I'm going to send the 2 here and here, the 3 here and here, and I'm going to cancel the bases in the same step. So 2 times 2x is 4x, and 2 times plus 4 is 8. 3 times x is 3x, and 3 times 5 is 15. Now I'm going to move everything to the same side. I'm going to minus 3, which gives me x. I'm going to minus 8, which gives me a 7. And I'm done. Now, again, I wouldn't put one of these in the review if it wasn't something you were going to see. Cough, 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 okay? When we have a fraction here, what we want to do is we want to be bringing this up. So whatever power we have that goes with the 64, and we are going to factor tree it to the side, okay? Whatever power we put with this 64 has to be negative to bring it back up top, okay? So I'm keeping in mind that it's going to be a negative exponent. I wanted to make sure to have that conversation with you. I know we saw it in our practice sheet, but we did that problem together, right? So we want to see it again so that you're able to reproduce that on a quiz. So I'm going to take the 64 to the side. I'm going to factor tree it. I'm going to do 2 and 32. I'm going to do 2 and 16. I'm going to do 2 and 8. And then I know 8 is a perfect cube of 2's. So 1, 2, 3, 4, 5, 6. 64 is 2 to the 6th. So I'm not going to make it 2 to the 6th in here. In order for it to be equivalent, it's going to be 2 to the negative 6th is the same thing as 1 over 64. Okay? Remember, the negative means change its location, and then 2 to the 6th would have been 64. So because this is a base of 2, I want this to be a base of 2. If I look here, 16, it exists right here. It's going to be 2 to the 4th power. So I'm going to have a 2 to the 4th is equal to 16, and then I'm going to raise it to 3x plus 1. At this point, both my bases are the same, so I can cancel them, and I'm going to use my power rule to distribute my exponent through. So negative 6 times x is negative 6x. Negative 6 times negative 2 is positive 12. 4 times 3 is 12x, and then 4 times positive 1 is just plus 4. I'm going to add 6, that's going to give me 18x. I'm going to minus 4, which is going to give me an 8. I'm going to divide 18, and I'm going to get 8 over 18. They're both even, so I could reduce that to 4 over 9. And my answer is 4/9. Fractions are numbers. Okay, folks, don't be intimidated by them. They could happen. So if in our original problem we see that it's a fraction under like some number under the 1, make sure you model it with a negative exponent, right, to change that location, and then you would just distribute the negative through. There are a handful of those on your quiz. I also attached, I think, 4 on that review sheet, and you can check out those if you need to and do the key. I put 2 of these on the review sheet if you wanted to give those a go. If they're still confusing, feel free to hit me up during office hours tomorrow, 1 to 2. The last thing you're going to see is going to be a couple multiple choice word problems, okay? So you're going to have an answer to choose from, which is nice because it's going to make you feel pretty confident about if you got it right or wrong, okay? So if you do a bunch of work and your answer doesn't match, check if you rounded correctly. And then if it still doesn't match, then you probably made a mistake. Go back and try again, okay? So let's do 2 of these. This one's harder. This one's a little bit easier. There are 2 problems on your review sheet. They're both as hard as you'll see on the test. So the initial number of bacteria in a culture is 12,000. The culture doubles every day. Okay, so write an exponential function to model the population of bacteria after x days. So this is going to be a y equals ab to the x because it doesn't tell you compounding interest. Okay, now they're telling you it doubles. So our growth factor is going to be times by 2, right? That means our b value is going to be times by 2 each time. And a is always what we start with. In this case, we are starting with 12,000. So we're going to have 12,000 times 2 to the x equals y, where x is going to be your amount of days. Okay, so there's our answer for part A. We just plugged those things in. We didn't actually have to calculate our growth because they told us it's doubling, so it's going to times by 2 every day. Next, it asks us how many bacteria are there going to be after 6 days. Okay, so I'm going to take this 6, I'm going to plug it in for this x right here, and I'm just going to PEMDAS it. So it's going to be 12,000 times 2 to the 6th power. So 2 to the 6th we've done a handful of times. It's not something I have off the top of my head, but I feel like I have it here, right? 2 to the 6th is going to be 64. So I'm going to take this number, 12,000, and now I'm going to times it by 64. And remember, I could have just done this on my calculator, right? So 12,000 times 64, so let's pull back up that calc. 12,000. Ooh, not 12,000. I don't need to put that in there. There we go. 12,000 times 64 equals, whoa, 768,000. Now that's crazy, but if you think about it, this number is going to double, right? So the first day it's going to be 24, then 24 is going to double. It's going to become 58, then 58 is going to double. It's going to be 116. So you can see just by the 4th day, it's over 100, okay, when it started from 12 because the fact that it doubles every time, okay? Because we are dealing with a word problem, we should put some sort of label on this. This is talking about bacteria, so it should say bacteria. If it's money, we should put money, and we should round to the nearest penny, which we'll see in this next problem. Okay, actually here we're talking about students. So if we're talking about students, we probably should have a whole number there. Okay, we're not going to have half a person or 0.35 of a person. So let's take a look at this. A college with a graduating class of 4,000 students in the year 2008 predicts that its graduating class will grow 5% each year. Okay, so they're giving us a rate of growth. Write an exponential function to model the number of students y in the graduating class 2 years after 2008. So it's going to be in the form y equals, they're giving you an initial amount, but then here, because it's growing by 5%, we're actually going to kind of use the p to the 1 plus, instead of r over n, it's just it's only growing this much each year. It's only being compounded once a year. So I could say my n is 1, or I could just say it's going to be r, right? Because r over 1 is going to just be r. And then 1 times our n times t, if n is 1, it's just going to be t here. So I can simplify this. I know my initial starting amount is going to be 4,000. So I'm going to have y equals 4,000. Okay. That's where I started. Then I'm going to have 1 plus my rate. Now my rate is 5%. I got to change that to a decimal. This is kind of like our compounding one. So 1.05 to the t. So the 1 means keep the whole percent, right? We want it to be growing, so it has to be greater than 1. If this was just 0.05, that would be that it's decreasing, right? And it's decreasing by actually 95% there. That would be a huge change, okay? Here, it's growing because it's greater than 1 by 5%. So yeah, there's my equation. Now, if they ask me a follow-up question like, how many people could you expect in 2018? That would be 10 years. I'd plug in a 10 right here. What if they asked, how many kids in 2020? That's 12 years from 2008. So I'd put 12 in for time, raise it to that power, and then multiply by 4,000. Okay? So you could be asked to write an equation. You could be asked to solve for a given time in an equation. Okay? So just do your best. Remember, you can always send me an email. I should know when you're taking that test because I'll be sending it to you and you can ask questions. Okay, I can also make myself available to you folks via Zoom. Speaking of available via Zoom, tomorrow I am holding office hours. I'm happy to go over any of the problems on the review sheet if you need to, and or if you want to take your quiz during that time, that would be great because if you have any questions, you could pop on and ask during office hours. Just let me know what your plan is. Okay, folks? Otherwise, I am signing off. Last official video, signing off. Good luck. I hope to hear from you if you need help. And I will see you guys around, maybe even next year. Okay? Bye.